Hi, everybody. Wanted to take some time to talk about another regression analysis. This one is from an interesting paper that was just released a little while ago. And the paper is called The Consequences of Faculty Sexual Misconduct. Very timely topic because the former president of Harvard, Larry Summers, an economist, one of the most prominent economists in the United States, was implicated in a set of emails with convicted sex trafficker Jeffrey Epstein. Uh, Larry Summers' emails suggested he was seeking advice from Jeffrey Epstein about a relationship with a junior professor. So the issue became very alive here in the economics department around the country. And Larry Summers has apparently been suspended from teaching his courses at Harvard University. He released a statement saying he was deeply ashamed of his conduct. So this paper, which was written by Sarah Cohodes at the University of Michigan and Catherine Leu at the University of Michigan, is a pretty timely paper. It just came out really at the same time as this. So let's ask what they measure and what relationship they estimate in this paper. So here's the abstract of the paper. I'll just read it because it's important to have a good idea of what it says. Faculty sexual misconduct targeted at students is a widespread problem. The consequences of such incidents include direct harm to victims, may also entail a loss to science, or social science or humanities, if students who encounter misconduct become discouraged from continuing their studies in the chosen field. We link publicly available information on degree completion by institution, academic field, meaning your major, and gender, to a database of faculty sexual misconduct incidents verified in the media or court cases. Then there's a little bit technical stuff about what kind of regression they run, and the results are exposure to field specific, meaning your major, specific faculty sexual misconduct incident decreases degree completion in that field by 3.4% 4 years after the incident. This decline is driven by incidents occurring after 2015, among which we observe a 7% decline in field, meaning your major degree completion. Students exit majors dominated by men, but this shift has little effect on predicted earnings. So they also include predicted earnings. So their regression has this outcome. Their unit of observation is the students in the major at institution of higher education at a university or college. So it's students in the major of an institution of higher education. The outcome variable is what's the graduation rate of those students in that major, and the explanatory variable is was there a sexual harassment incident, sexual misconduct, I guess I call it, sexual misconduct incident in that major or at that university. We'll look and see what the regression says, right? So the thought experiment that you imagine is if you're students and you and a major and you hear about or you know somebody who experienced this kind of harassment, does that affect your graduation rate? On average, does it affect graduation rate of other students? Does it affect graduation of next year's students? So what's the effect of this, not just on the year it happens, but several years after the incident, which might be reported in student newspapers or just by word of mouth, people become aware of this. So that's the general abstract. The general regression should be pretty clear what they're estimating, what the relationship is. You should think about threats to validity of this estimation, what could be possible threats to validity. But and remember, we have a number of threats to validity. Omitted variable bias, sample selection bias, reverse causality or joint causality, and measurement error in the X variable. But let's go ahead and jump to their regression analysis, which the main one is on page 39 here. So let me just, sorry for the skimming over. There we go. Here's their main table. Tables 4 and table 5 are the main tables. So table 4 is the impact of faculty sexual misconduct on undergraduate degree completion. So they take the log of the degree completion. So the degree completion is a rate, I guess. It's the percent of people who graduate. So this is the log of the percent of people who graduate. It's not totally clear here in the table exactly how degree completion is being measured. It's presumably the percent of people who complete their degrees. So then they take the log of that. So it's the percent change in the percent is how we would interpret it, the percent change in the percent. And Here, our key variable here in the regression is the something they calculate is because the event will have an impact the first year, then the second year, third year, fourth year. So this is, I guess, the impact after 4 years of the incident, and the effect is for men is negative 0.05, so 5% reduction in degree completion. For women, it's 1.5% reduction in degree completion. For all people, it's 3.4% reduction in degree completion. Now, they have one asterisk here, and that's P at the 0.05 level. So these two coefficients are not statistically significant by our convention. So we might ask, well, what is the p-value of this coefficient? Plainly, the p-value of this coefficient is not even close to statistical significance. The p-value for this one is 34 divided by 21, which is about 1.5, right? So it may be, I think they said in the paper, they report its p-value of 0.13. So it's there, not statistically significant by our convention. Explaining why the main effect is reduced degree completion by men in the field is, not obvious why the effect would be mostly on men. I think naturally most of us would think that most sexual misconduct is targeted at women, so it would be women who would be most likely to withdraw from the field. So they find that it's negative, but not statistically significant. If we go to so you should look at the other, how many, what are the observations here? This is in-field degrees. So we have 200, say 300 institutions. We observe them for 40 years. And then maybe there's 50 majors within each field. So it's 300 institutions, 40 years times 30 majors. That presumably adds up to something like 900,000 observations. Here we have only the institutions, not all degrees. So it's the number of institutions, 300 institutions times 40 years. And I'm not sure if that adds up to 100,000, 200 or 300 times 20 years, 40 years, I'm sorry. 300 times would be 3,000 times 4 would be 12,000. So I'm not sure why there's a discrepancy here. So exactly what these number of observations are. But not so important, right? Let's go on to the next table. So the next table restricts the sample, right? So we do a subset, or they do a subset of the sample. And the first sample consists of what they call early incidents, and the second sample consists of what they call recent incidents. And the difference is that the early incidents are between 83 and 2014, and the later incidents are 2015 to 22. So focusing on the more recent incidents, we see that we get negative and statistically significant coefficients for all of the three main specifications. That is, we look at it here. For women, there's a 6.5%. Remember, the outcome is the log, so it's interpret the coefficient as percent, 6.5% reduction. For men, it's an 8.6% reduction, and overall, it's a 7% reduction in graduation rate 4 years after uh, the the misconduct incident. So we have basically it's what we've called in class a difference in difference specification, where we have the uh, a dummy variable in some sense for whether it was before or after the incident, and then a dummy variable for whether the school had an incident. So we're comparing degree completion rates in schools that didn't have incidents to degree completion rates in schools that did have incidents. And then we're comparing before to after the incident. So it's a double difference that we're measuring here, the same specification we've talked about in class. So I hope you find that interesting and useful, and I've posted the tables and the paper so you can take a quick look at those.